Alright, hello everybody, welcome back. Carl again. Today I'm going to talk about my Arduino based pH sensor. I ordered this on eBay from this gentleman here. I believe that's Reza Hussein. I know I'm pronouncing that wrong, I'm so sorry. From South Dakota. And he's selling this on Tindie as well as eBay. I actually bought two of these, so I've had one on my fish tank for a little while now. And just want to show you, this is how it comes. Nice little bubble wrap envelope. Comes in a static shield bag. And I just already cut the tape. And here is the board. And what I really like about this board is, it looks like it uses a really nice BNC connector. It even has a thumb screw here. And you see all the components are service mount. It looks like it's professionally done at a board assembly warehouse. There is a little flux residue here and on these header pins, so I'm assuming that he solders the BNC connector on, and then the 0.1 inch male headers. And one thing I really like about this board is it is galvanically isolated. There's a couple devices here. One is a PIC. I believe it's the MCP 6001, which is just a real kind of generic op amp. There's an analog devices part here, and then the last one is I believe it was the DC to DC converter for the isolation. There's a couple other little SOT 23s here. Anyhow, it speaks to the Arduino over i2c, which is really nice. It comes with a bunch of extra headers, so if you don't want to use the male headers, you can actually solder your wire in. And there's just some information on the back of the board here, and I'll put the links in the description down below. Alright, so originally I was using this board, and this was a board that I designed in EagleCAD. And this is not my design. This is actually based off of a practicalmaker.com. The gentleman's name over there is Andrew, and he designed a board like this. And when I went to buy it, he didn't have any. Now, one thing about Andrew's site at Practical Maker, it's all open source. So he put the original schematics up, and he had a two-sided board. I redid the board so that it was single-sided, using all of his design. And this was the original board I had. Now, the way it worked is, I added these little jumpers so you could select which analog pin you would read the BNC from. It has an op amp here. This is a Maxim 1044, which basically gives you positive and negative voltage. So you have positive and negative 5 volts, and then 2 trim pots. Now, this is fine, in my opinion, if the only thing you're running on the Arduino board is this. When you start running other devices that cause changes in voltage, that causes change in your pH, because the way he has the code set up, it reads the voltage from the Arduino pins, the 5 volt nominal, and if that changes just a little bit, then that'll tweak the value. And I just couldn't get a stable reading out of this. It's also very tedious to calibrate with these little pots, and these are good 15 turn pots. It's just very tedious. And so this worked for a while, and I've done a couple different revisions on this board, but this board here is about a year old. So I've been using this board for about a year. I think I have 3 different models. Now, in fairness to Andrew, here's another one I designed here, and you see I just extended the BNC board. I made the board, I extended so I could try to get it to fit on Arduino as a shield. And I etched these boards myself. So here's another one I had, and let's see, this one is not quite a year old. So anyhow, what I was saying, in fairness to Andrew, he has actually designed this board, which is a auto-compensated model, where you plug it in, and then in his sketch you program in your pH solution, your standards, and it actually auto-calibrates it for your probe. So very much like this one from Reza from Tindie, the one I got on eBay here. He has a very similar sketch. His sketch is super simple to use. The only thing I don't like about his sketch is there's not a ton of comment, and it's kind of confusing at what's going on. I'm not a programmer by day, so I don't know a lot about programming, but I have been playing around with the Arduino development environment for a couple years now, and I've learned a good amount from, you know, videos and reading, so I know enough. Anyhow, so he does have this board. However, it uses EEPROM data, and I couldn't figure out how to take this sketch and embed it to my program. The other thing is, this is really hard to surface mount. He uses this little tiny chip for the negative voltage. You can see the trace I actually broke, so I had to run kind of a jumper wire. And then he uses a small Texas Instrument op-amp, which is fine. I was able to solder that on, no worries. And then he uses surface mount components, and I just changed them to regular components. So this does work. I just can't seem to figure out how to embed it into my current Arduino sketch for my Aquarium computer. So that's why I bought this. Alright, let's talk about some pros. What I really like about this is a nice small form factor. In mine, I actually put in a Radio Shack enclosure. I was able to drill a hole, mount this in through the side, and then I ran just a small wire from here out, and that runs to my Arduino. So what's really nice is I can, my BNC probe, you know, it's only a couple meters long, and here's what I use here. So this is the probe that I use. This is a cheap little $8 eBay probe. So, you know, you have this cheap probe, and, you know, I don't know, maybe 16 or 18 inch lead that's to BNC. This is real cheap and generic, and I wouldn't recommend getting a cheap and generic one. They're a pain in the butt to calibrate. They're cheap. You get what you pay for kind of in the pH probe. My advice is to get a good $40 probe from maybe Pinpoint or Neptune or Apex or Reef Keeper, one of those good probes, and then you can put it on this board. So what's really nice is my, you know, fish tank is 4 foot long, and I have the probe kind of mounted literally on the other end of the tank, so it's 3 feet away, and my electronics away from the water so they don't get ruined. And you see that in the previous video. So this metered cable just isn't long enough, so I have to put this bulky cable on, this BNC cable, and I just didn't like it. So now with the i2c, I actually mount this on a small box. It's fairly watertight. I mount it nice and high in the stand, run the wire to the Arduino, and this can plug in here, you know, no problem. So I really like that. The other thing I really like is it looks like it's using nice high quality BNC connectors, and it's using good, you know, analog devices parts and microchip part. And I can't remember the brand of this DC to DC converter here. I can't recall off top hand. So the only thing I'll say that I don't like is the sketch is a little confusing. I wish there was a little more commented about what's going on. And then, you know, really when you're talking about Arduino, it's not open source. So that's kind of the downfall. Somebody asked on his blog, hey, is the board files, you know, open source? He said no, it's a closed design. So nevertheless, I picked this up for about, it was less than 20 bucks. I mean, you really can't go wrong. Even if it was open source, you know, and this is really more directly for Reza. Even if it was open source, I don't believe you could buy all these parts and have a custom manufactured PCB for less than 20 bucks. I just don't believe it. I mean, a board of this size, you're probably talking $20 for 3 of them at OSH Park. So you're talking, you know, small scale production here. If I was to bake it myself, so I need 3 of them at $20 and all these parts. I just don't believe that I could get this quality of a board for less than 20 bucks. So really, buying it from him just makes total sense. Just do it. Don't even worry about it. Again, you can see here of all these previous attempts at making a pH shield, and I actually have another one. I have 4 of these boards, so I easily have $20 from, you know, in parts on these boards when I could have just bought one of these. And now I actually have 2. So I have one that's going to stay on my system, and then I'm going to calibrate this one to this. Okay, so what I'm going to do, I'm going to take this board, this pH probe here, I'm going to mount it in this enclosure that I started to make. And this is just a regular LCD, on-off switch, a DC-in cord here, and in here what I'm going to do is mount an Arduino board, just a bare bones Arduino. You see I have some headers for the LCD display, and I'm going to mount this in here like this. And then I'm going to have a mobile pH probe, so I can stick this in my, when I'm mixing salt water, I can stick it in there and see what the pH is without using those test kits. So that's why I bought another one, and that's just going to fit perfect in there. And then my Arduino will sit here. I'm going to use just a regular Arduino chip. Now, the other downfall is with using i2c, it's not quite as simple to get it work on an ATtiny. If I can get, and I'm going to work on that using an ATtiny 85, which is really small part. There is an ATtiny wire library, which is supposed to be somewhat compatible with the Arduino wire library. But I might try to get that working in the future, actually installing this software on an ATtiny, and that'll be perfect. A little 4-pin chip, it'll just be perfect for this. So, the other thing I thought about doing was, if I do an ATtiny for the LCD display, I'll have to use an i2c LCD driver, because obviously I won't have enough pins. And then I'm pretty sure the sketch is bigger than 2K, so you can't use an ATtiny 23. So you're kind of stuck with using the full-size Arduino. Alright, I'm going to take you to under the tank and show you the box that I put it in. Okay, so here under the stand, I'll come up, there's the pH probe, kind of like a little splash shield I made. I know they said they're supposed to be waterproof, but I made that a while back when I was having kind of inconsistent readings, and I just wanted to eliminate that as a possibility. And you see the black wire runs up to there, and then there's the box. Out of the way, nice and dry. So you have the B and C connector on the left, the wire comes out to the right, and it runs up, and then just to give you an idea of how far away that is, you know, the stand's here, and all my electronics are mounted behind this white plywood to keep the water electricity separate, and that's where it comes down into the Arduino. So again, I really like the i2c, you know, using that bus. Alright, well, that's going to conclude the video. Thanks very much for watching. If you have any comments, please place them down below. Also remember, just take that extra second, hit that like button, let me know that you like this type of video. Kind of encourage me to make more. I'll put the links again for this pH board, and also I'll put Andrew's site on there as well. You know, one kind of side note, measuring pH is a very difficult process. You know, the Arduino really can't read negative voltages very well, so that's kind of why everybody uses the positive and negative voltage supply. So that's one of the downfalls. And of course, at pH 7, it's supposed to read 0 volts. So again, that's the kind of drawback to pH. So anyhow, again, hopefully this was useful. Again, questions down below. Thanks for watching.